The notes for 1.6 today are about solving linear inequalities. There's a couple of definitions that it would be helpful to start by reviewing. A linear inequality is a statement that two expressions are either greater than, or equal to, or less than or equal to. So less than is the same as if a problem says fewer than or if something says below. The symbol for less than looks like this. And when you graph it on a number line, it's going to have an open circle. So that's not the number 0. That's just a circle that's not closed in. Is less than or equal to is the same as each of these verbal expressions. And so less than or equal to, this symbol, when you graph it on a number line, it'll have a closed-in circle. Greater than and all of these other wordings that means greater than would have an open circle. And then is greater than or equal to and all of these other verbal expressions that means is greater than or equal to, that one's going to have a closed circle when you graph it on a graph. Identifying these inequalities in word problems is helpful because you'll be encountering word problems in this section. A school bus can seat at most 50 students. So the number of students that are on the bus, we'll use S to mean students. The number of students on the bus, if it can be at most 50, that means it can be anything less than 50 or anything up until or equal to 50. So you would use the less than or equal to symbol to represent this idea of it being at most 50. B is different though. Children must be at least 48 inches tall to ride the roller coaster. So the height of the child, we can use H or any letter to represent height, at least 48. So it needs to be greater than or equal to 48. At least, in this example, indicates that 48 is the smallest it can be, and it would need to be anything greater than or equal to that value. When we look at inequalities and see how they're graphed on number lines, in example number 3, the circle gives you the number that's going to go in the inequality. If it's closed, it'll be or equal to. If it's open, it won't have the or equal to part. And then if it goes to the left, it's less than, and if it goes to the right, it's greater than. We're not given a variable to use in either of these problems, so we can just use x if we want to. X is less than or equal to 2, and on this one it's x is greater than -3. So again, the number comes from where the circle is placed on the graph. The circle tells you whether to include the or equal to or not, and then if it's less than or if it's greater than, that tells you the direction that the inequality symbol should be facing. When we solve inequalities, we solve them very much like we solve equations. We just have to interpret their solutions a little bit differently. So A is less than 8 means that all of the numbers that are solutions to this inequality are the numbers that are less than +8. +8 gets an open circle, and then the direction of the arrow that you draw shows which way the solutions are located from that value. Over here on B, 1 is less than or equal to C. This needs to get rewritten because there's a rule that says that the variable always goes on the left when you're writing inequalities. So when you flip it around, the C goes on the left, the 1 goes on the right, and then the direction of the inequality sign also changes because you're reversing the order that it's written. C is greater than or equal to +1, so on this one, +1 gets a closed circle, and then the solutions are located to the right of that value. And so here we get x is less than +2. Let's see, x is less than +2. So here's my +2, and x is less than +2 would go this way. Here on D, be careful. So I'll minus the 4 from both sides. -x is greater than +4. And then here is a special rule of inequalities. Because I need to divide both sides of this inequality by a -1, the direction of the inequality sign changes. So that's going to happen anytime you multiply or divide both sides of an inequality by a negative number. X is less than -4. In these final two examples, we're also solving inequalities. There's just some extra steps in both of them. Combine like terms on this one. So 3m plus 12 is less than or equal to 18. And then once the like terms are combined, I'll just go through and finish solving it, again, using inverse operations, the properties of equality, like we're practiced previously in solving equations. So m is less than or equal to positive 2, closed circle on positive 2. And then finally on letter F, I need to start with the distributive property. So 2p minus 10. And then from there, we can combine like terms over here on the left. And we'll add the 4 to both sides. So we'll get 2p is greater than or equal to negative 7. Divide both sides by 2. And we'll get p is greater than or equal to negative 7 over 2. On this one, it's okay that it works out to be a fraction. When you graph it, just do your best. Negative 7 halves is negative 3 and a half. It's going to be a closed circle, and then it's going to be the numbers that are greater than that. So it's okay when you're doing it, just approximate where that goes on the graph down here. Some numbers will work out to be fractions. Compound inequalities are when the inequality has two parts to it. We have a definition of compound inequalities right here. There are two different types of compound inequalities. So on this one, the x is in the middle. It says x has to be in between negative 1 and positive 2. And the values that are solutions to this inequality would be the numbers that are in between those numbers. The x is in the middle, so you shade in the middle. This inequality symbol doesn't have the or equal to underneath it. So that's why this circle is open, and this one does, and that's why that circle is closed. Over here, you'll notice that this one has the word or in the middle. That means that you're going to graph each of these separately. X is less than negative 1. Remember, less than are the numbers that are smaller than. Or x is greater than or equal to positive 2. In comparing both of these inequalities, it's helpful to notice that on this one, the solutions are the solutions that are between the numbers. You could also think that the solutions are the numbers that are inside those two numbers that are your boundaries. And over here, this one has the or in it. On this one, the solutions are the numbers that are on the outside of the two numbers. And so it's helpful to see how those two graphs are different. If you were going to pick a solution to this compound inequality, you would pick numbers in between the numbers, and on this one you would pick numbers that were either less than the smaller number or numbers that are greater than the larger number. When we write compound inequalities, we want to recognize which of these types of compound inequalities we're looking at. Example number 5 says, write the compound inequality of the graph that's shown below. So on this one, you see that it's shaded in the middle, so that means that it's going to get written this special way where the x goes in the middle. The smaller number goes first, the larger number goes last, the x goes in the middle, and then it's the numbers that are less than or equal to 6 and the numbers that are greater than 2. Many students feel like this inequality symbol over here, that first one that gets written, kind of always looks like it's backwards. And that's because the 2 is on the opposite side of the x than we would normally anticipate. Down here, this one isn't the numbers in the middle, it's the numbers on the outside. So when the numbers are on the outside, we're going to use the word or, and we're going to write it as two separate inequalities with the word or in between it. So on this one, x is less than negative 5, or x is greater than positive 2. Both of those circles are open circles, so neither one of those inequality symbols has the or equal to line underneath it. When you write the answer to this question, though, make sure that when you write it with the word or, and then it's just one answer. They're not two separate answers to the question, it's one combined answer. Example number 6 is a small word problem just to get you thinking about the ranges of numbers. A speed limit on a local highway is 65 miles per hour. You will get a ticket if you are caught going less than 15 miles per hour under the speed limit or more than 10 miles per hour over the speed limit. The first part of the question wants you to write a compound inequality representing speeds for which you would receive a speeding ticket. So the first one is sort of like the bad part of the example because you're trying to figure out when you would receive a speeding ticket. We can let S stand for the speed that you're going. That can be how we define that variable. So here, if you're caught going less than 50 miles per hour under the speeding limit, or if you're caught going more than 10 miles per hour over the speed limit, then you would get a ticket. 50 is because the speed limit in the middle was 65, so I did 65 minus 15, that's how I got the 50. 75 is because more than 10, so I did 10 plus 65. So this would be the range of speeds where you would get a ticket. The second part of the question says, write a compound inequality that says when would you not receive a speeding ticket. So if you were going between 50 miles an hour and 75 miles an hour in this example, it says you would not receive a speeding ticket. So the inside is good in this example and the outside is bad because you don't want to get a ticket. Give two examples of driving speeds where you would receive a speeding ticket. So anything less than 50, so let's say you were going 35 miles per hour on the highway, that would be one example of a speed where you would receive a speeding ticket. And then what's another example? Anything greater than 75. So if you were going 85 on the highway and got caught going 85, you would receive a speeding ticket in this example. So both of these would be examples of times you would get a ticket. When we solve compound inequalities, we're going to go through and it's a little bit different than solving equations and solving inequalities, just the linear inequalities. When we solve this one, kind of think about it like it has three parts. And so I'm going to add the 10, add the 10, and add the 10. I add that value to all three parts. I'm trying to get the x by itself in the middle. So 6x is less than or equal to 24. And then to get the x all by itself in the middle, I'll divide all three parts again by 6. We're used to doing work on equations when you just do it to one side of the equation. But here there's sort of two sides to the equation, so it needs to get done in all the different parts. 6 divided by 6 is 1, these 6's cross out, and then this gives me 4. So my answer to the question, without the lines in the way, would look like this. It's an and inequality because the x is in the middle, and so positive 1 to positive 4, and then the x is in the middle, so the solutions would be the numbers that are in the middle. Example B is different because it has the word or in the middle, so that's how I know that I'm going to be solving this one differently. You can cover this part up. We'll solve this inequality first, and then you can cover this part up and solve this side separately. So these are not done in tandem with one another. They're done separate from each other. But once you're finished and you write the answer to the question, x is less than or equal to 5 or x is greater than 10, make sure that you indicate that this whole thing is the answer to the question and it must include the word or. X is less than or equal to 5, closed circle there, or x is greater than 10, open circle there for that one. So right here we can compare the answers to these questions to see how they're different. This one, the x was in the middle, so we shaded in the middle. On this one, there were two parts. We solved them each separately, and then we considered the answer to the question together. And so to finish, we just have one example of each left. Here, I'll add the 5 to all three parts. Please draw these lines if you find them to be helpful to you. Negative 3 is less than or equal to negative x is less than or equal to positive 10. And then to get the x all by itself, I'm going to need to divide it all by negative 1. So that's going to give me positive 3 is, when I divide by a negative 1 right here, my inequality sign changes direction. And so that's the rule that we practiced on the front side of the notes. Because you divided by a negative 1, these two numbers are backwards. They're in the wrong spot. So when we write our answer to the question, we want to flip-flop this whole inequality. And so the numbers for this one, written the way that you'll most commonly see it, where the smaller numbers on the left and the bigger numbers on the right, x has to be in between negative 10 and positive 3. And again, the solutions for this one are the numbers that are in between them. So when I rewrote it, I just took the whole inequality and I just wrote it completely backwards. And then finally, to finish up for this one, this is an or inequality. So you solve it in two parts. And then I'll solve the second part over here. So for this one, it contains the word or, so my answer is x is less than or equal to 2 or x is greater than or equal to 6. This is my solution to the inequality, and then to graph it to show the solution set on the graph, x is less than or equal to 2 or x is greater than or equal to 6. Be careful with your open and closed circles here.